So today's lesson is proportional relationships and constant proportionality. So we dealt with proportional relationships, we dealt with equivalent ratios, and now we're going to talk about a constant proportionality. So I hinted at you already you've been using this for a while. You just didn't know what it was called, maybe, but we're going to dive into it more with an equation. So let's start our solve it. Jamal can run 1 mile in 5.05 minutes. If Jamal maintains this pace during a 5 kilometer or 5K race, he expects to break the course record of 15.25 minutes. Is Jamal's expectation reasonable? Explain. Okay. So we've got to do some math here and figure out. We know what he does or how many minutes he runs a mile in, but do we know his rate of speed based on kilometers? We don't, but what we can do, and I did a little research, find out that 5 kilometers is 3.1068. So I'm just going to call this 3.11. Or to keep it simple, we could call it 3.1 and not carry the extra one. And the reason I would not carry that extra one in this case, and we can round up a few seconds if we want to. So what does that mean? Well, we can take this and say we've got 1 mile is 5 minutes and 5 seconds. Then what do we multiply by to get 310 or 30? Was it 866? Sorry, I'm kind of changing my mind, aren't I? 686. So get rid of that. It's 686. And the reason I decided to go ahead and carry this is what we're going to do is find that hidden multiplier. Like, what do we multiply 1 by to get here? So I could choose that to be whatever I want, 3.1, 3.11, 3.1068. It's an easy multiplier to find. It's exactly what it is. That's how we got there. So then we could take that same number and multiply it here. And that's where you're thinking, well, am I going to want to multiply all those digits? Well, if I want to be crazy accurate in the sets that we're trying to break a course record, you probably do want to be incredibly accurate and not round this. But for our case and making some of the math a little bit simpler to discuss, we're going to do 3.1. And what we're doing is a little bit longer of a distance. Therefore, if the time is going to meet it, we know he's got a little bit of cushion. So we need to find what is 5.05 times 3.11. So 1 times 5, 5, 0, 5. Bring down, and then 1 times those again, it's 5, 0, 5. Bring down 2 ones to 3 times 5 is 15. 3 times 0, but carried that 1. 3 times 5, another 15. And now we can add this up. 5, 5, 10, 7, 5, 1. And then we need to move the decimal place. 1, 2, 3, 4. So 15.7 minutes. Do you think it would have mattered if we had rounded this a little bit differently? Do you think he's still going to make us 5.25 minutes? I think there's too much of a gap between the 0.25 and our 0.7 that he's going to need to try to increase his rate down.